Hello, my name is Keshwani. That's K-E-S-H-W-A-N-I, Keshwani. We are here because we want to improve our geometry skill. Today is our lesson number 3, day number 3, right there. Today we will talk about the concept of surface area of a rectangular box. It's a very straightforward, simple concept, and yet sometimes I find students getting confused in it because they sit there and try to memorize the formula. What I want you to do today is to make sure that you don't have to memorize the formula anymore. I just want you to understand the concept, and as long as you understand the concept, it's very straightforward, very simple thing. As long as you understand how to figure out the area of a rectangle, the rest is very simple. The area of a rectangle, you know how to figure it out. If you have a rectangle here, the area is going to be length times width. Very simple, very straightforward. Here's your length, here's your width, and that's the area of a rectangle. What do we mean by surface area of a rectangular box? For that, we have to first understand the word surface. I know it sounds very ridiculous, but be patient and just listen to what I have to say. The English word surface is made up of two parts. It is made up of a prefix, sur, which comes from the French word sur, which means above or on something. Above something or on something. And then of course the face. So literally it means on the face. When French talk about sur le table, they're talking about on the table. So that's where the prefix comes from, sur, which we pronounce as surface, on the face. So when we talk about surface area, we're talking about area on the face. The question is, what does it mean? What do we mean by a face, and how many faces does a rectangular box have? A rectangular box has 6 faces. We'll see this in a sec. We'll see it in a second here. Let's draw our rectangular box. So here's our rectangle, and what we want to do is draw a rectangular box out of it. Let's draw a rectangular box out of it. And then of course we have to show the inside part. There. These corners that I just showed you here with the red dots, we have the name for it. In mathematics we have a name for it, a name for them rather. We call them vertex. Vertex. What does vertex mean? Vertex is just a fancy way of saying a corner. Vertex is just a fancy way of saying a corner. So in geometry, when you have a picture, here's a picture here. Each one of them is called a vertex. All of these corners, these are all vertex. And I paused here just now because I said these are all vertex. That actually was not proper English. We have to understand. We have to know what the plural of vertex is. Plural of vertex is not vertexes. The plural is vertices. Even though we are in today's lesson, we are not here to learn vertex and vertices. We are here to learn surface area, but it doesn't hurt. This is useful information that you need to have. You have to understand the terminology. You have to understand the lingo. You have to understand the concept before you can have any hope at all of doing the problem properly on the exam. So if they talk about vertex of a picture or vertices of a picture, and if you don't know what vertices means, then you're pretty much done because you're not going to be able to finish it. That's what it is. These are all called vertices. Let's start with here. Let's talk about the first face. A, B, C, D. That's the face. That's called one face. It's going to have 6 faces. A, B, C, D. That's one face. A, B, C, D. Similarly, it's going to have the face in the back. I'm going to show you actually a rectangular box so that you can actually, so it makes it easier for you to picture it. I'm holding in my hand here a rectangular box, as you can see here. A, B, C, D. That's one face. Similarly, it has a face in the back, right here. We have to give these vertices name. We're going to have to give these name. We already called them A, B, C, D. Let's give these name in the back. So a comparable concept for A, B, C, D would be A, B, C, D, E, F, G, and H. So E, F, G, H. E, F, G, H. Just now I used the word comparable. I want you to learn this word properly, comparable. And if you want to learn it properly, and of course you do, if you want to learn the word properly, you can go to, I'm digressing right now. Digress means to go off a topic. I want you to go to Keshwani Prep vocab day 2. Just type in Keshwani Prep vocab day 2 and you will learn the word comparable. I want you to learn it properly. It is not to be pronounced comparable. Many a times I have seen students go around pronouncing that word as comparable. There is no such word. It is to be pronounced comparable. And the word digress means to go off topic, which you're going to find on day number 3. Just type in Keshwani Prep vocab day 3 and you will learn the word digress, which means to go off topic. So the comparable concept, I wanted to digress here because I wanted to talk about the word comparable, which is why I had to introduce the word digress first. I'm done digressing now because I wanted to talk about the word comparable, as I said. We're done with it. So we have A, B, C, D, which is the front face here, A, B, C, D, and the comparable face in the back would be this part right here, which we're calling here as E, F, G, H. Let's talk about the one on the top, B, E, F, C, or rather, B, E, F, C. And similarly, we have the bottom, A, H, G, D. A, H, G, D. The rule is that you have to go either clockwise or anti-clockwise. You cannot mix it up. You have to go clockwise or anti-clockwise. You cannot go A, C, D, B, or A, C, or A, D, B, C. No. You have to go either clockwise, A, B, C, D, or anti-clockwise, A, D, C, B, A. Anti-clockwise, or as you guys like to call it, counterclockwise. So we took care of 2 more. We have 2 more to go. So we took care of the front face, A, B, C, D. We took care of the front face. We took care of the back face. We took care of the 2 faces on the top and the bottom, B, E, F, C, and the bottom one, A, H, G, D. Now we have to take care of the 2 sides. Let's start with this one here, C, F, G, D, C, F, G, D, C, F, G, D, and now this one, A, B, E, G, A, B, E, H, rather. That's it. Those are the 6 faces. But if somebody asks you to find surface area, you don't have to go through all of this nonsense. You just have to understand the concept, and once you understand the concept, then the rest is very simple. So let's figure out the surface area of this thing. So remember, a rectangular box has 6 faces, as you can see there. And we have to calculate the area of each of these 6 faces and add them up to find the total surface area. We have to calculate the area of each of these 6 faces, each of these 6 faces there, right here. So this is A, B, C, D, and this is the comparable face, and so forth. That's why I use the word comparable. These are the comparable faces, this and that. They go in pairs. So we have to calculate the area of each of these 6 faces and add them up. to find the total surface area. Now, as I explained before already in my first two videos on day 1 and day 2, and for those of you who still do not know what I'm doing here, in the first few days, maybe the first 5 or 10 days or so, what I'm doing is I'm covering the basic concepts in a lot of detail, as I'm doing right now, in excruciating details. I want to make sure that you understand the basic concepts, and once you have understood the basic concept, once you have covered the basic concept, then I'm going to start solving the problem, geometry problems for the SAT, GRE and GMAT, and at that point we'll pick up the speed. And if at any time I feel that I need to refer you to a particular concept, I'll just tell you to go and watch that video on that particular day, and you will go and watch the video. In case you have trouble remembering how to figure out surface area, you can always come back to this video and watch it. So there are 6 faces. All we have to do now is find their area, and finding the area of each of these 6 faces is very simple. It is it is same as finding the area of a rectangle. That's all it is. So let's give this thing a dimension so we can figure out the surface area. Let's pretend that A to D is 7 feet. Let's pretend that A to B is 3 feet. And B to E is 4 feet. So ABCD here, ABCD is just 7 by 3. 3 feet by 7 feet. 3 times 7 is 21, and feet times feet is feet squared. So 21 feet squared. I have here DCFG. What do you suppose that is? DCFG. What do we call it here? We called it. Very good. DCFG is what I'm calling CFGD. CFGD, same thing. So D to G is same as B to E, which is 4 feet, and F to G is 3 feet. So CFGD is 3 feet by 4 feet. 3 feet by 4 feet. 3 times 4 is 12. 12 is square feet. And finally, we have BEFC. 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 BE is 4 feet. And E to F is same as A to D, which is 7 feet. It's 4 by 7. Which is 28 feet squared. Let's add them up. 8 plus 2 is 10 and 11, so that's 1. And then 5 and 6. Looks like 61 square feet. Now remember, we have ABCD and then we have one in the back. So that they are in pairs. So we have to take this entire quantity and multiply it by 2. Because we calculate the area of the three faces, and then we just take multiply it by 2 because to get our 6 faces. One in the front, one in the back, one on the top, one on the bottom, one on the left hand side, one on the right hand side. There you go. So the surface area, the total surface area of this rectangular box is 122 square feet. 122 square feet. How do you figure out the area of a cube? A cube, surface area of a cube. I'm not doing a good job drawing a cube here. There is no difference between finding the surface area of a rectangular box and finding a surface area of a cube. It's the exact same thing. It's just that when we're talking about a concept where the length and the width and the height happens to be the same, we no longer call it a box, we call it a cube. That's what cube means, all the sides are equal. So finding the surface area of a cube is exact same as this one. No difference in the concept at all. But because the length and the width are the same, we just have to figure out one Once you have the one face, all the 6 faces are of the same dimension, so you just multiply it by 6. That's all. So it's faster. That's all. But anyway, this was the total surface area of this rectangular box. Turns out to be 122 square feet. Later on, we'll talk about the concept of volume. Surface area of anything, or actually what I meant to say is area of anything is a two-dimensional concept. Area always has two dimensions. It has the length and the width. When we talk about the volume is a three-dimensional concept. I want to cover it separately. Volume is going to be a three-dimensional concept where you're going to have the length and the width and the height, and therefore it's no longer going to be measured in square feet or square yard. Three-dimensional concepts are measured in cubic unit, cubic yards and cubic feet. We'll come to that. Let's see, when do I have that planned? Perhaps next day, who knows, tomorrow. I'll look it up and tell you as to when we're going to do the volume. Well, tomorrow we're going to do, I had planned tomorrow to do volume of a cylinder, but we can do the volume of a rectangular box tomorrow. That's what I will do. Alright, so I'll see you tomorrow on day number 4 when we'll talk about the volume of a rectangular box and a volume of a cube. This was it for today. I will see you tomorrow on day number 4. In the meantime, if you wish to get hold of me for personal private tutoring for SAT, GRE, GMAT or TOEFL or geometry, algebra, statistics, what have you, you can go to any of these website addresses that you see there and send me an email. Or you can go to keshwaniprep.com and send me an email from there. But this was basically. Understand the concept so that you don't have to go through this much detail and so this much amount of work next time. It's very simple. There are 6 rectangles, 6 of them. Figure out the area of each of these rectangles and just add them up, and that you get your surface area. You get the area of this rectangle, which is same as the one in the back, and you figure out the area of this rectangle, which is same as this one. You find out the area of the rectangle on the top, which is same as the one in the bottom. So you find out the area of the 3 rectangles, add them up, multiply the whole quantity by 2 to get your 6 faces, and that's it, you're done. I'll see you tomorrow, okay? Thanks.